This is an organ itself. It has tissues. It has cells. It needs the blood supply. That's what this is on the outside. This is the coronary circulation. Makes sense? There is a difference, major difference that we're talking about. Okay? We're going to come back to it, but I need you to keep that concept in mind. Okay? Not only is the heart a pump itself for blood, it needs its blood supply also. And that's the coronary supply. Okay?
That's just for the heart.
That's just for the heart itself, nothing else. That is only what you see on the outside. Yep. Now, some other parts of the heart that are really cool. In between the atria, we've got a separation, the interatrial. Inside the heart, when we open this up, okay, we have something pretty special for the muscle makeup, and it's called pectinate muscles, ridges of myocardium. Look at your structure. All right, look at this internal structure. Ridges of myocardium. Okay? Right atria and the auricles. The auricles are these little flaps. Okay? Look like little wings. It kind of looks better on this side. Okay? If you look at this piece, see how not so much, depending on which model you've got, but you can kind of see these ridges that they're trying to show us in this makeup. The little lines. Okay? Interventricular septum. The muscular wall that's separating the ventricles. And you gotta love this term right here. Okay? Somebody was inventive in lab that day. Trabeculae carneae. Say that 10 times real fast. Okay? Internal ridges in the ventricles. They're trying to give you some ideas of those over here. Okay? They're kind of showing them pretty good. They're kind of cool. Our chambers. Right, left, right, left. Atria, ventricle, atria, ventricle. We got some really huge arteries and veins that are going to come off of this. But wait a minute. Is there other stuff in this structure we haven't looked at? Yes. They're really kind of cool, okay? The valves. What's the purpose of a valve? That's what I was dealing with on Thursday with my water at the house. The valve. And what was supposed to be one-way water flow. Not in Dr. Young's world. Now, The valves, their job, keep it moving in one direction. Okay? We're going to have our atrioventricular valves. Take the term apart. Between an atria and a ventricle. Between the top and the bottom. One on the right side, one on the left side. Now, the right one is our tricuspid. The left one, mitral, formerly known as bicuspid. The cusps are what they're referring to, because when you take a cross section through the heart and you look down into it, one of them has 3, one of them has 2. Therefore being tri and the bi. Ever heard of stuff going wrong with those? Oh yeah. They can now do valve replacement. Ever heard of that? Okay. If you ever have to have that, get the pig one. Okay. Don't do the one that's man-made. Get the one that's from the pig. Okay. Trust me on that. Now, that tells me my right, and they're trying to represent it with these little pieces of just like paper, okay? The right is the tri, the left is the bicuspid. But do you see something kind of extending off of those? All right, they're trying to show it was like this little stringy stuff coming off of those valves, okay? Chordae tendineae, tendinous cords. That's what these are, okay? Tendinous cords. What these do, they connect the valves, the tri and the bi, to papillary muscles that you find on the floor of the ventricles. Find those little cords and trace them down to where it looks like they're trying to attach. And it looks like something kind of thick and sausage looking. Looks a little bit like a sausage. All right? That's your papillary muscles. Okay? They're the valves, okay? What we're trying to do when the ventricles contract, we want to make sure that there is control of the blood flow. Because basically when we have the blood return to the heart, it's under very low pressure. And it's going to fill the atria. And as it fills the atria, we need it to begin to move into the ventricles. All right? All of this flow of the blood is going to be based on pressures. All right?
So if you have high pressure, does it take longer for the blood to fill up? It's faster?
It's faster, but it may actually not be filling up properly. So you might not get a proper fill, which means, but the pumps, the contractions can be harder, okay? And that makes the pressure going into the tissues and the systemic and the pulmonary circuit too under higher pressure. And you think about that, if it's under high pressure, it can actually burst the tissues. No, this would be like, for example, somebody who has chronic high blood pressure, because that contraction of the heart is so hard. And if you think about one of the first organs that this blood is going to hit is the kidneys, okay, for filtration. What's the number one, like the top organ that somebody with chronic high blood pressure gets affected? The kidneys. Because what happens is, and you'll learn this when we talk about the kidneys, that pressure that goes into the kidneys and it goes into the nephrons, it bursts the nephrons. And they no longer work. And that's kind of sad. Right. So it's going to be trying to control the blood flow. Then the other valves that we're going to have are semilunar. All right? Lunar means moon. Okay? Semi, somewhat shaped. Okay? So if we look into our heart, hold it upside down, look into the heart this way. All right? First of all, what color are we talking about for the blood that's going into the pulmonary circuit? Blue. All right? So look at your blue artery. Okay? That's going to your pulmonary circuit. What does that look like? I see 1, 2, 3 little valves. Those are semilunar. Now kind of tilt it just a little bit and look just below that. What major artery is that leading to? That's coming from the left side of the heart, the aorta. Aorta, cut that grass over there. So 1, 2, 3, okay? Those are my aortic valves. All right? So those are my semilunar. So I've got atrioventricular, semilunar. Okay, I knew that was going to happen because it just was not staying on there very well. There we go. All right, so those are our valves that we're going to have. We were to take a cross section, that's how they would look. Left, right, aortic, pulmonary. When the blood moves, we're going to find that ventricles, we have our period of relaxation and we have the period of contraction. This is being done 24/7, 365, 366 if it's a leap year. I don't care what happens. Your ultimate cause of death is always the heart stopping. You can have this cancer, you can have this disease, I don't care what it is. The cause of death is always the heart stops. Now, think about that for a second. You had to tell this organ to do this 24/7, 365. 366 if it's a leap year. I don't know about y'all. I wouldn't last very long. Okay? Because I don't remember what I did this morning. So I doubt very seriously I would remember to tell the heart to beat. there are events that occur when these ventricles are going to relax and contract. The events that occur, they're going to actually control or play a major part in the movement of that blood. All right? Now, I'm going to try to do a ventricle, an aorta. All right? Got a valve. Just one side I'm looking at. Okay? Now, pressure. What did he say about pressures? The heart's concern is pressure. Doesn't care about anything else. I loved how he was like, it doesn't care if you read it a poem or not. I was like, that's so funny. Okay. Now, at the time when this ventricle is relaxed, that pressure begins to drop. Because that ventricle, if it's relaxed, it's kind of doing, all right? Right? Now, think about it. If blood is up here in the atrium, and that pressure relaxes in the ventricles, what do you think is going to be able to do for the blood in the atria to the ventricle when that ventricle relaxes? That blood is going to be able to flow easily into the ventricle. Does that make sense? Mm-hmm. Because if the ventricle is relaxed, this cusp of this valve has that chordae tendineae attached to a papillary muscle, which is part of the ventricular wall, and if it's relaxed, that's pulling down on the cusp. Is that correct? Mm-hmm. Therefore, the cusp is open. If that cusp is open, blood gets to do this number. Does that make sense? Mm-hmm. Now, the blood flows from the atria to the ventricles.